Today we're going to talk about exponents, and before we get into the properties of exponents, I want to make sure we understand why we have exponents, okay? So basically we have exponents so that you can do shorthand and you don't have to write x times x. Instead of x times x, we're going to write x squared. That's the purpose of exponents. So that way, instead of writing x times x times x times x times x, and this is 1, 2, 3, 4, 5 times, I can write x to the 5th power. Okay? So that means if you see x to the 20th power, that means it's x times x times x, and that's going to be 20 times. That's what that means. And you have what's called the base. So my x would be my base, and then in this situation, my 20 would be my exponent. Okay, so the base is what's being multiplied over and over again, and the exponent is how many times you do it. Okay? So that's why we have exponents, so that we can shorthand and we don't have to write everything over and over and over again. Okay, the first property that we have here listed is the zero property. Now, you might see these properties in a different order, but either way you have, it's the same 7, okay? So the first property here says it's the zero property, and it's in the name. Like, notice that the exponent is a 0, so that means that's why it's called the zero property of an exponent, because the exponent is a 0. Now, any example of this is any number to the 0 power. So it can be x to the 0 power is 1. It can be 1,427 to the 0 power. That's still 1. Okay? So any number to the 0 power is 1. Then we have the negative property of exponent. Obviously, it's called the negative property because you have a negative exponent. Notice we have b to the negative n. What this is saying is that any exponent that's a negative, if you want to make it to a positive number, then you have to take the reciprocal of it. Okay, so we have 4 to the negative 2nd power. And if I want to make that negative 2 into a positive 2 exponent, I'm going to put this over 1, and I'm going to take the reciprocal. Remember, reciprocal means we switch the numerator with the denominator. So that means it's going to be 1 over 4 squared, and now it's a positive. And it works both ways. It works if it had been at the denominator, then we would have just moved it to the numerator instead. Okay? The third property here is talking about the product property, because product means you're multiplying. So I'm multiplying these two bases, okay? And this says m plus n. So that means that when you're multiplying two bases, and what you do with the exponents is that you add the exponents, okay? So if we have 5 squared times 5 to the 4th power, notice they have to have the same base for this, for you to be able to use the product property. So that becomes 5 to the 6th power, okay? Because we're adding 2 plus 4. Now we have the quotient property, and the quotient means division, in case you don't remember what quotient means. Now, when we multiplied two bases, we added the exponents. Guess what? When we're dividing these bases, we're going to subtract the exponents, okay? So that means first off, we have to make sure we have the same base. So let's do 7 to the 8th power over 7 to the 3rd power. So we have the same base. And what we're going to do is we're going to subtract 8 minus 3. So we get 7 to the 5th power. Okay? And this works with any number, as long as you have the same base. Then we have the power of a power. So that's in the name. You're taking the power, that's n, of something that already has a power of n. And in this case, you're going to multiply. So notice the difference between the product property and the power of a power. So with the product, we have the same base, but each of those bases has their own exponent. With the power of a power, we just have one base, and that one base had an exponent, and then it's going to be in a parentheses, and then it's going to be to another power again. So that's when we multiply those two exponents together. So let's say we have 3 to the 4th power, and then that's the first power, and then power of a power, and let's say we have 5. So we're going to multiply 4 times 5. So 3 to the 20th power. 4 times 5 is 20. Now we have power of a product property. So notice the name power. So we have an M, and then product means you multiply two numbers together, or you're just multiplying numbers together. Can be more than two. So what happens is that the exponent is distributed to both of those bases. So it's distributed to the A, and it's also distributed to the B. Notice right here what happens. You have A to the M power and then B to the M power, okay? And I'm going to use variables for this, x, y to the 7th power. And we have x to the 7th power and y to the 7th power because that 7 gets distributed to each one, okay? And then the last property is power of a quotient. So remember, quotient means division. So that's why we have A divided by B, A over B. And then the power here is M, okay? So we're going to distribute that M to both of these bases. So I'm going to use X over Y. So that is the quotient, that's the division part of it. And then let's say we have to the 3rd power. So it's going to be X to the 3rd power over Y to the 3rd power, okay? And these are the properties of exponents, but this is the most basic form of them. The properties of your exponents, so you can remember them. They're in a different order, but it's the same properties. Okay, so the first thing I want you to do is treat this as 3 different problems. So you have 6 times 2, which we know how to do. That's 12, okay? And then I'm going to rearrange this so that my x's are next to each other and my y's are next to each other. So x cubed, x to the 5th, y to the 4th, y to the 2nd. Now, even though we don't see that multiplication sign, that's what's happening here, okay? We're multiplying these numbers together. So remember, we look at our exponent properties, and this is going to be, we have the same base and we're multiplying. So what happens is we're using A, which means that you're going to add m plus n. Okay? And so what we're going to do is we're going to combine these, and I have 12 x to the 8th because 3 plus 5 is 8, and y to the 6th because 4 plus 2 is 6. Now, even though some of these look pretty complicated, you want to break them down so that you're looking at individual things like I just did right now. I looked at the numbers individually, the quotients, then the x variables, and then the y's, okay? So let's look at number 2 since it's similar, and then we'll do number 3, and then we'll do number 2 after. So we have a 2, and since we don't have another quotient, then we're just going to leave that 2. We have our x's that are together. Remember, we add our exponents. So 9 and negative 7, that's going to be x squared. 9 plus negative 7 is x squared. And then we have y to the negative 3 and y to the negative 4. And that becomes y to the negative 7. Now, you don't want to have negative exponents. When you're simplifying all the way, that means once you simplify all the way, you won't have negative exponents, okay? So how do we get that negative 7 to be a positive? Well, if I look at f, that property tells me that if it's a negative, I have to take the reciprocal, which really means like y to the negative 7 was at the top, and we're going to bring it to the bottom. And that's how we make it a positive. So I'm going to go ahead and I'm going to erase this because I've already moved it down and I've already made it a positive. And I don't need to simplify anything else. That's simplified all the way. Okay, so I moved it over here so that I have more space. Once you practice simplifying exponents, you won't need as much space anymore because you'll be able to do things in your head. But for right now, I want us to break it down separately, okay? So we have 3 over 18, and we know how to reduce a fraction. So that means that that's going to be 1 over 6. And I'm going to cross it off, not because it canceled, but because that's my way of knowing that I've already simplified that. So I have negative 1/6. And then I have x to the 4th over x to the 6th. Now, this is a quotient, which means division, and we can subtract 4 minus 6. So I'm going to have 4 minus 6, which is x to the negative 2. But remember, we don't want to have negatives. So I'm going to leave this alone for now. I'm going to keep this as x to the negative 2nd power. And then I'll come back to it and I'll make positives. So I'm going to extend this line because now we're going to have some things at the top and some things at the bottom, just like we did before, but we're going to have to move some stuff around before we simplify all the way. Okay, now let's take a look at y to the 10th over y to the 5th. This one is a quotient, so we can just subtract 10 minus 5. Okay. And I'm crossing these off because I've already gone through them and I've already simplified them. But I did them in 3 steps. You don't have to do them in 3 steps. You could probably do these in your head once you get better at exponents. But right now I just want to show you each step. Okay, and then the final step is we don't want to have any negative exponents. So we're going to keep stuff at the top and we're going to have stuff at the bottom. So what stays at the top? We have the negative 1, which we don't normally write negative 1, so I'm just going to write negative. Y to the 5th, because that's a positive exponent. And 6 is definitely at the denominator, so I'm going to write 6. And then because I want to make this a positive 2, this x squared does have to come to the denominator. So that becomes x squared, and now it's positive. And that's my final answer. Okay, let's try another one. Okay, here's number 4, and I rewrote it so we have plenty of space. Now, the first thing I'm going to do is I'm going to reduce my coefficients. I don't need to worry about the exponents right now. I want to reduce the coefficients first so that I have smaller numbers to deal with. So 28 divided by 2 is 14. Okay, and I'm going to make a fraction because there's definitely going to be a fraction no matter what. Okay, now that I've reduced my numbers, and I'm going to cross these off just so that I know that I've dealt with them, not because they cancel out. And now I'm going to make these negative exponents into positive numbers. So remember what happens is we just switch them. We take the reciprocal. So x to the 8th goes on top, and x to the 1st power goes at the bottom. Okay? I'm going to go ahead and reduce this. That's a 6. That's a 3. So I can subtract those. And that's going to be y to the 3rd power and then x to the 4th power. Okay? And now I can go ahead and reduce this one. X to the 8th over x to the 1st power is going to be 14x to the 7th power. And I can write everything together, and then after that, I'll combine my x's. So now everything's all in one instead of 2 different parts. And I can combine my x's. That's the only thing left to do. So we have 14. And then we have x to the 7th times x to the 4th, which it is still multiplication. So that means we're going to add the exponents. So that means 7 plus 4 is 11. and then y to the third power. And that is our final answer. Okay, so I want you to pause the video right there and try out 5, 6, 7, and 8. Come back, I'll show you the answers for 5 through 8, and then I'll also go over 9 and 10. You can try 9 and 10 on your own if you feel like you're up for it already. For this one, for number 7, the only reason that this is the only positive is because we have a -1 and it's to the 4th power, so that is a positive 1. All right, I know number 9 looks pretty gnarly, but if we break it down, then it should be okay. So you want to have plenty of space. You want to look at every single one individually. So I'm going to start with looking at this first section, okay? 3 squared and c squared, because remember you have to distribute that 2 to each one of those. So that's going to be 9c squared. And I like to cancel out my stuff when I've dealt with it, okay? So again, that 2 is distributed to both of them. So we have c squared and d squared. Before moving on to the next part, I want to simplify this first term. So I'm going to make this 9c to the 4th power, d to the 2nd power. Okay, now we're all done with this first term, and I'm going to move on to the second term. Remember that 2 is distributed to every single term inside the parentheses. So 2 squared is 4, and then that's 2 times 2. So c to the 4th, d to the 4th. And luckily I don't have to do much to this one. That's already simplified because I can't combine c and d together. Okay, now I can move on to the last term, and remember to distribute that 3 to every single term. So 4 to the 3rd power is 64, and that's c cubed and d to the 6th power. Unfortunately, since we don't have all of these variables with the same exponent, we can't simplify this anymore. So this is actually our very long answer. We would only be able to simplify it if this was like C4 and D4, then we could put these together because both of the variables have the 4th power. Or if it was like C3, D6, then we could combine these two together. But since they're all different, meaning they all have a different variable, C4, C4, C3, D2, D4, D6, then we can't actually combine them together. Okay, number 10, the first thing we want to do is we want to separate it, okay? So we actually have 2 separate things going on here, okay? So we have 25 x to the 4th y to the cubed power over 5xy minus 15x squared y to the fifth 5xy. And I'm doing this so that it's easier for you to see how it's simplified, okay? All right, so remember what I told you is to go step by step. So let's do the numbers first, coefficients, then the x's, and then the y's. So 25 over 5 gives me 5, and I'm going to cross it off because I've already dealt with it, not because it's canceled. X to the fourth over x, remember that has a 1 right there, so it's actually 4 minus 1. So the 4 minus 1 gives me x cubed. Y to the third, and then y to the first power. So that's 3 minus 1, y squared. Okay, now we can look at the second term. So 15 over 5, that's 3. X squared over 1, that's 2 minus 1, so just plain old x. And then y to the fifth over y to the first power, and that is y to the fourth power. Now, once again, we can't combine these because they have, the x's have different exponents. This has a 3 and this has a 1, and the y's also have different exponents. So it would have to be the same for both, the same exponents for both the x and the y for us to be able to combine that together. And that is my final answer. Okay, and here's all 10 answers.